on the unit circle, I know this is 180. This just goes up by 15. So this is 195. That's not actually on the unit circle. This is 210, 225, and 240. So whenever I see 230 degrees, I'm just going to go sort of like in between here. And then I've got 4.5, so rather than going out 4, I'm going to go 4.5 circles. So 1, 2, 3, 4, and 0.5 right there. And so remember, if you think of this, all these circles, the coordinate plane is really just like you took the regular XY plane and you put a bunch of circles connecting all the, like here, all the 1s are connected here, all the 2s are connected here, all the 3s. So I'm looking at X and Y. If I'm estimating, I can see over here, it looks like my X coordinate is pretty close to negative 3. Looks like my Y coordinate is maybe like negative 3.5. But I want to know what that exact coordinate is, not just the estimate. So this point right here, if I connect it back to the origin, I know the length of that segment right there is 4.5. And then I know the angle all the way around is 230. But if I'm going to make this a right triangle right here, then I need just this angle inside of the triangle. How would I find it? Okay, we can subtract 180. So if I do 230 minus 180, I'll get 50 there. So this angle right here is 50 degrees. And your horizontal part of your triangle, that's your X. Your vertical part, that's your Y. So if I want to find the X, that is my adjacent side. I know the hypotenuse, so adjacent and hypotenuse, that's cosine. So we'll say cosine of 50 equals X over 4.5. And so we'll multiply both sides by 4.5. And 4.5 cosine 50 is going to give us 2.893 is our X. And then our Y here, that's opposite and adjacent, opposite and hypotenuse. So we're going to say sine of 50 equals Y over 4.5. And so we can multiply both sides by 4.5. And so 4.5 sine of 50 is going to give us the Y equals 3.447. Okay, now what you've got to be careful about this is that we're in the third quadrant. So this is going to give you positive values whenever you do this trick right here. But we're in the third quadrant. So in the third quadrant, my X is negative and my Y is negative. So whenever I write this here, I'm going to have negative 2.893, negative 3.447. So we also have to be able to convert rectangular to polar coordinates. So I have made myself an overlapping rectangular and polar coordinate graph. You guys could just mark here. Mine's a little bit off, actually. So if we're going to convert 2, 4 to polar coordinates, we're graphing over 2, up 4. So that's going to end up right here. And to have polar coordinates, we need to know the length of that radius, and we also need to know that angle. And it looks like the angle is a little bit more than 60, and it looks like the radius is about 4.5, but we've got to get precise answers for that. So we're going to do much the same as we did on the last problem. We're just kind of going backwards. We'll make ourselves a right triangle. And the length of this side is 2, and the length of this side is 4. So to find the radius, we're just going to have to do Pythagorean theorem. So 2 squared plus 4 squared is going to equal r squared. So we've got 4 plus 16 equals r squared. So 20 equals r squared, and we will square root both sides. So r is the square root of 20, or 4.472. And then we need to know the angle here. So for the angle, you technically could use sine, cosine, or tangent since we have all 3 sides now, but I would use tangent because that's opposite and adjacent, and those are the 2 sides that you don't have to round. So you'll say tangent of theta equals opposite over adjacent, so 4 over 2, and then you'll do tangent inverse. And tangent inverse of 4 over 2 is going to be 63.435. And so 4.472 is our radius, 63.435 is our degree. Okay, questions? Right here. It's supposed to be a 2. Okay, questions? Alright, let's try another one. We'll have some visitor behavior sounds. Okay, so we're going to convert -3,7 to polar coordinates. So this one's going to be a little bit harder because it's not in the first quadrant. So on, let's change something right here. Let's make that a 4 so it'll fit better. Why is it not letting me type? Let's change this to a 4. Negative 3, 4. We can do the same thing, of course, for 7. It's just a little bit quicker. So if we're graphing negative 3, 4, we would count over 1, 2, 3, and then we would go up 1, 2, 3, 4. Get this point right here. And you can also do this on the just the regular paper without the coordinate graph there. So negative 3, 4, we're going to draw this point right here in. That is our radius. And we need to know the angle. The angle we need to know is this angle right here. However, whenever you make a right triangle over here, we're going to have to find this angle first. So I'm going to just call it like angle A right here. So we need to find this angle first, and then we can use that to find the angle, because the angle that we're looking for is your unit circle sort of angle, where you start at 0 and go counterclockwise over here to this radius. So this was a negative 3, so I know this side of the right triangle is 3. This is 4 here because my y-coordinate was 4. This is technically a negative, but when you're doing Pythagorean theorem, distances are positive, so I'm going to make that a positive here. So whenever we're looking for the radius, since we've made a right triangle, we can just do Pythagorean theorem. So we're going to have 3 squared plus 4 squared equals that radius squared. So 9 plus 16 equals the radius squared. And then so we'll have 25 equals the radius squared. And some of you are saying, oh, Miss Hyatt, you could have done that so much easier because it's a 3, 4, 5 triangle, so you should already know that. But our radius there is 5. So in our polar coordinate, we know that 5 is our radius. Then we are going to find the angle. Okay, so when we're looking for that angle, Trevin, looking at that right triangle, what do we need? What trig identity do we need to use to find angle A here? It's going to be sine, cosine, or tangent. We'll use tangent. So how do we set it up? Tangent of A equals what? 4 over 3, because it is opposite over adjacent. And so we are going to solve this by doing tangent inverse. And so when we do tangent inverse of 4 over 3, we are going to get 53.130. Now, that is angle A. That's 53.130. That is not our answer, because remember, we need this unit circle value over here. We need this theta right here. So, Sadie, what would we do to find that angle right there? Okay, so we know that's 180, right? And so we could take the 53.130 away from it, and that'll give us our angle. So we'll do 180 minus the 53.130. And whenever we do that, okay, so 126 point, and let's see, that'll actually be 870 if you round it to 3 places there. Okay, and so that is those are our polar coordinates. Remember that I told you guys that on the final exam you get to use Desmos, and there'll also be a section of your test where you get to use Desmos on the exam. So if you, wrong one. Desmos will not graph polar coordinates, but it will graph negative 3, 4, which is the point we just had to graph. And you can go over here to the wrench and you can change your background to the grid. And notice right here it's in radians. I can go down here and change it to degrees. And so I can't tell for sure, but I can see that, let's see, that would be right there perfectly on 5. And I can also see the angle is a little bit past 120. So an angle of 126.87 looks reasonable there. So while you can't solve this problem using Desmos, you could make sure that your answer looks reasonable here, because it'll graph things perfectly for you there. All right, questions? All right, so let's do one more thing. All right, so we are going to convert x, y to polar coordinates. So in this case, we do not have numbers. We just have x and we have y. And these are rectangular coordinates here. So if I have a graph, I don't know if x and y are positive or negative or what the coordinates for x and y are. I'm going to draw them like they're positive just because it's a little easier to. So if I had the points x, y, then I would go over to x and I would go up y. Right, and that would give me my point. So that means right here I would have a radius. This is the angle that I would be looking for. And if I made a right triangle, then the length of this side right here would be x. And the length of this side right here would be y. So I need to find r, and I need to find theta. So that's what I'm looking for. Obviously, I'm not going to get a number answer here because I don't have any numbers in the problem. What I'm going to end up with is more of a formula. So if I want to find r, then r is the length of that hypotenuse, so I've got to do Pythagorean theorem. So I would do x squared plus y squared equals r squared. And I want an answer where I've got just r equals something. So if I need to get that r by itself, Richard, what would I have to do to get that r by itself? Square root. I would square root both sides, right? So that would tell me r equals the square root of x squared plus y squared. So that, in essence, is your formula that you could use if you wanted to find if you wanted to convert your rectangular coordinates to polar coordinates. If I want to find theta right here, and I don't want to use r because r is something that I've had to find itself. If I want to find theta right here, and x and y are the two sides that I have, then Jade, what trig function are we going to have to set up for that? Tangent. So we would say tangent of theta would equal y over x. And so to do this, we would do tangent inverse. So we would have theta equals tangent inverse. Tangent inverse, or inverse tangent, of y over x. That's a negative 1 right there. It keeps wanting to run together. There we go. What you have here, this is a formula that you could use to convert polar to rectangular to polar every time. So if you just, you still may have to look at your angle a little bit, because if you end up in third or fourth quadrant, it's not going to give you the correct angle, actually second or third quadrant. It's going to give you the wrong angle, and you'll have to figure out where it's at. But this is a formula you could use. Now, I'm teaching this to you last. I could have over here just said, here's the formulas, plug the numbers in. And you would get the right answers. But what I find is a lot of times students don't remember these formulas. But you do remember how to do Pythagorean theorem, and you do remember how to set up your trig. So I, myself, don't really use these formulas right here very much. If you are a person that just likes the formulas, that gives you some structure, then you can memorize these formulas. It will give you the right answers. I generally just I'd try to generalize more on that. Okay, questions on that? All right, let's see. There was one other thing. No, there wasn't. I think I saved it for the next part. You don't really need it. No, we're good. All right, so now what we're going to do is I have an assignment for you out of your book to practice these a little bit. And let's see, where did I write it down at? It is right here. Page 572, 14 through 25. It's just a little more practice with us converting polar coordinates. We've still got like 35 minutes left. We might have time to finish these so that we can go over them before you guys leave. So go ahead and get started on that. Also, if you'd like to use the polar graph paper, if you need some more, there is some up here. You can grab some. Am I running low? Let's see. Don't, okay, share there. We still need some more. All right. Yeah, this works really well. I recently got this one because we all had the smartboard version of it, but mine quit working because I've had it for like 12 years. So this is what they got as the replacement, but it's